Today we're going to talk about solving quadratic inequalities. So the difference between this and the equations is that it will involve greater than, less than, greater than or equal, and less than or equal symbols. So we're going to look at it graphically. And I have a couple examples here to start with. The first one says a parabola opening downward. Where does the function less than 0? So we want to look, here is where y equals 0. So at this point and at this point is where the graph, the function, goes below 0. So if we look at the beginning value, it's at 0.2, and the ending value is at 4, or 3.8, a little short of that. So it would be x is less than 0.2 or x is greater than 3.8. If we were to write it in interval notation, it would be negative infinity to 0.2, parenthesis, because all of these values to the left give me this graph down here. Union 3.8 to positive infinity, because all of the values bigger than 3.8 give me this part of the graph down here. This also asks, well, where is the function greater than 0? Greater than 0 means above y equals 0. So here's where the graph goes above y equals 0. So as we notice, that happens from 0.2 through 3.8. All of these values go above 0. So in interval notation, it would be 0.2, 3.8. But what if we had a graph that opened upward and we used the same expressions? So in this case, it is asking the same questions. Where does the function less than 0? This time, less than 0 below y equals 0 happens down here. So it is the x values from 0.2 through 3.8. The next question asks, where is the function greater than 0? The graph goes above this y equals 0 at this point and at this point. So it is the x values to the left of 0.2 and to the right of 3.8. But what if our parabolas do not cross the x-axis? What if instead I have a double root? So here's an example of a double root. And this is asking, again, the same question, where is the function less than 0? Here is my y equals 0. Does this graph go below that? No. So it is no solution. But what if instead the question asked, where does the graph go greater than 0? Here is y equals 0. It goes greater than 0 all places. But since there's no equal bar, I would say all reals except at 2, because that is exactly where it equals 0. And we can have a graph that doesn't even touch the x-axis. So let's see what that same situation, same questions, come out to be. Where is the function less than 0? Here's my y equals 0, and the entire function is less than that. So it is all reals. Or in interval notation, that would be from negative infinity to infinity. Or the question could ask, where is the graph greater than 0. Here's my y equals 0. Does this graph ever go above it? No solution. Okay, let's look at this graph. It is asking, where is the function less than 0? Less than 0 happens here and here. So what values does it begin with? To the left of -2, union to the right of 3. The next question says, where is the function greater than or equal to 0? Greater than or equal to 0 happens here. Since that equal bar is in there, we would include the values. So it starts at -2, and all these values go above. So through 3, bracket. Right? Remember when you're solving inequalities that greater than means disjoint and less than means conjoint. And this will work when you're doing your algebra and you make sure your variables always stay on the left side of the inequality. So first of all, I like my square values to be positive. So I would divide or multiply everything by a -1. So that would give me x squared plus 9x minus 36. Multiplying by a negative will flip my sign, less than 0. Now we can factor x and x, factors of 36 that differ by 9, 12 and 3. A positive 12 will give me a positive 9, a -3. So here, x would equal -12, or x would equal 3. And if you want to use this idea, less than is conjoint. So this would be from -12 to 3. And it was no equal bar, so it would be no brace, parentheses. The other way you can look at this is draw a number line. We start at -12 and we start at 3. -12 is a 0, so I'm going to put a 0 on it. All values to the left of 0 are negative values. All values to the right of 0 are positive values. I also had a 0 at 3. All values to the left of 0 are negative. All values to the right of 0 are positive. So if we look at this, we have right here up to the 0, a negative times a negative gives me a positive. A positive times a negative gives me a negative. And a positive times a positive gives me positive. I am looking for those less than 0. That means negative. The negative values happen from here to here. Gets you the same results. But some of you may like it graphical rather than memorizing. Greater than is disjoint, less than is conjoint. Okay, let's try the next one. X squared minus 5x plus 6 is less than or equal to 0. So we can factor x and x, the factors of 6 that add up to 5, 2 and 3, sum, same sign, negative, negative. So x is 2 and x is 3 are your roots, are your zeros. So again, it was less than, so it will be conjoint. But there was an equal bar, so I would use my brace from 2 to 3 brace. Or graphically, I'm going to move this down a little bit. We had a 0 at 2 and a 0 at 3. Anything to the left of a 0 is negative, to the right is positive. Anything to the left is negative, to the right is positive. Negative times negative gives me a positive. Positive times negative gives me a negative. And positive times positive gives me a positive. Less than means negative, so again, that occurred in between. Let's try the next one. 2x squared minus x is greater than 3. We always want it to be 0, so we go 2x squared minus x minus 3 is greater than 0. And now we want to factor 2x and x, factors of 3, 1 and 3, 1x, 6x. Is their difference 1? No, so let's flip the 1 and 3. Inside I have 3x, outside I have 2x. Now I have a difference of 1, but I need it to be negative 1. So that's there. So first, positive is second. So here, 2x minus 3 equals 0. Add 3. 2x equals 3. Divide by 2. X is 3 halves. And here, x is negative 1. This time we had greater than. Greater than means disjoint. So I would be to the left of the smallest value, negative 1, no equal bar, union to the right of the bigger value, 3 halves, to infinity. And if you want to see it graphically, negative 1 and 3 halves are my zeros. To the left of a 0 is negative, to the right is positive. To the left is negative, to the right is positive. Negative negatives, going to give me a positive. Positive negatives, going to give me a negative. And positive positives, going to give me a positive. Greater thans are positive. So positives happened from here on and from here on. Okay? You should now be ready to do your assignment.